Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Syabram bin Syaimi from LO1 T1.
Hi, and I greet you guys. My name is Muhammad Hafiz Imran from L1 T1.
Hi, my name is Muhammad Shazwan Nafiq bin Rosdi from LO2 T2.
Hi, Assalamualaikum and a good day. My name is Muhammad Rafizal Muhammad Sapian and I'm from LO2 T2.
Hi, Assalamualaikum. I am Abdul Rahman bin Abdul Razak from LO1 T2.
Hello. For my task in my group is to explain about our mini project. So our mini project is to explain and calculate the stages and to do the prototype using the waste material. So this is our prototype. First prototype is pack column distillation process, and this is second prototype.
Okay, for the pack column distillation process, distillation is a process by which a liquid mixture is separated into fractions with higher concentration of certain components by exploiting difference in relative volatility. In industrial settings such as oil refineries and natural gas processing plant, this separation process is undertaken using a distillation column. Okay, the distillation objective is to take a liquid mixture and separate it into two or more streams which have composition. This is the vapor and this is the liquid. To the feed stream. In the basic distillation column, a feed stream enters in the middle of the column and two streams leave, one at the top and one at the bottom. Okay, let me introduce you the function of the reboiler, mixer, reflux control and the distillate receiver. So the reboiler, a heat exchanger at the bottom of the column which boils some of the liquid leaving the column. The vapor generated returns to the column at the bottom of the stripping section. In the mixer, we use ethanol and water and the mixture goes to the distillation column, which is then distillate the mixture and then goes to the condenser which convert the gas product into the liquid. For the reflux control, a portion of vapor from the top of the column which has been condensed to a liquid and returned to the column as a liquid above the top tray. For the distillate receiver, is used to measure the volume of liquid collected from the distillation and then goes to the top product. First of all, we mix the ethanol and water into the reboiler and it boils and then goes to the mixer, and the mixer goes to the distillation column which is distillate the mixture, and then this is the top product and the bottom product goes downward. From the top product, it goes to the condenser and then goes to the some of the mixture goes to the distillate receiver and the reflux control, and then from the reflux control, it went back to the distillation column to increase the purity, and from the distillate receiver, it used as a storage and then goes to the top product.
Okay, Assalamualaikum. Now, I'm going to explain about the construction of McCap tail graph. So, this is an example of a question, and we must construct a McCap tail graph to find the number of stages. So now, for the desired product, we must find the stages for methanol. So here the feed line, the concentration of methanol at the feed is 0.4 and the concentration of methanol at distillate is 0.97 and the concentration of methanol at bottom product is 0.02. So now here is an example of a complete McCap tail graph. So here we plot the concentration at the x-axis, then we draw a line. We stretch a line from the bottom to the 45-degree line, which we first must contract the 45-degree line. Then we must plot the points for the equilibrium curve. After we stretch the line from the x-axis, then we must draw a Q line. So for the Q line, for a cold feed is more than 1, which is in this area, and for saturated liquid is equals to 1, so it is straight, and the partial vapor is between 0 and 1, the value of Q. And for saturated vapor, the Q is at the Q is 0. So from here we must for Q is 0, we must pull to the y-axis. Okay, then for superheated is Q is less than 0, so is particularly in this area. So then we must draw a rectifying operating line, which can be calculated using using this equation, which is 1 over reflux ratio plus 1 times with the concentration of the distillate. And then after we got this number, the value for ROL, we plot the value here at the y-axis, and we make a line from the xd to the value of ROL. Next, we must draw the stripping operating line. To get a stripping operating line, it is obtained when the intersection between Q line and the ROL line. So for this question, we get the intersection is from at here, and we stretch a line to the XB line, and then only we can calculate the number of stages. Okay, for the first stage, we must make a line. We can start constructing the stage from the XD line to the equilibrium curve, and it will end at the ROL line and continue until the stages is before the Q line. So after the stages pass the Q line, the line will stop at the SOL line, and the number of stage will end at the XB point. So if we want to then we must subtract 1, because one stage is for the reboiler. So from there we can get the number of theoretical tray, which is from this question is 7, but we must minus 1, so it equals to 6 stages. For that is how we construct a McCabe-Thiele graph. Thank you.
Hi and Assalamualaikum again. So my task today is to explain and a little bit of introduction about what is gas absorption really is. So what is gas absorption? Absorption or gas absorption is a unit operation used in a chemical industry to separate gases by washing or scrubbing a gas mixture with a suitable liquid. The fundamental physical principle underlying the process of gas absorption are the solubility of the absorbed gas and the rate of mass transfer. One or more of the constituents of the gas mixture dissolves or absorbed in the liquid and thus be removed from the mixture. In some systems, this gaseous constituent forms a physical solution with the liquid or the solvent, and in other case, it reacts with the liquid chemically. So, next, for the purpose of such scrubbing operations may be any of the following. First, gas purification. For example, the removal of air pollutants from exhaust gases or contaminants from gases that will further process. Second one is product recovery, or we call production of solution of gases for various purposes. The absorber in gas absorption column may be a pack column, a plate column, spray column, venturi scrubbers, bubble column, falling films, wet scrubbers, and stirred tanks. So, there are several factors need to be considered in gas absorption process. First, gas solubility. The gas solubility should be high, thus increasing the rate of absorption and decreasing the quantity of solvent required. Next, volatility. The solvent should have a low vapor pressure to reduce loss of solvent in the gas leaving an absorption column. Third, corrosiveness. The materials of construction required for the equipment should not be unusual or too much expensive. The fourth one, cost. The materials of construction used in this process must not be too expensive because it can cause a lack of budget for the process to be achieved. Viscosity. Low viscosity is preferred for reasons of rapid absorption rates, improved flooding characteristic in pack column, low pressure drops on pumping, and good heat transfer characteristics. The solvent required for this process should be non-toxic, non-flammable, and chemically stable. Thank you.
Alright, okay, now we will show to you how the gas absorption operates. Before that, I will show to you what is the component in the gas absorption. Okay, first of all, this is water tank, the source of water. Then this is the bottom product, where the water that mixed with harmful gas will be. Okay, then this is the harmful gas source, and this is the flow where the pure gas will go. Alright, now this in the packet column there will be a packet bag that will filter the gas, the harmful gas. Okay, how the gas absorption operates. Okay, first of all, the harmful gas such as chlorine or CO2, carbon dioxide, will flow into the packet column gas absorption. Then it will go into it and filter by packet bag. Okay. Then the water from water tank will flow into the packet column and will mix with the harmful gas in the packet column. Then will go to the bottom product. The gas that have been separated by harmful gas will go to the pure gas line.
Okay, hi, assalamualaikum and a good day. So, I will briefly explain about how to plot the graph for gas absorption. So in gas absorption, there will be two cases in plotting the graph, which is first the stagnant and the equimolar diffusion. I'm sorry. So what I have for you today is the graph for equimolar. This is from a question, example of question from Madam Aziati tutorial in the VLE. So I will explain to you on how to plot the graph perfectly. Okay, first, in the question, there will be a data given to plot the equilibrium curve. From the data given, we need to plot this curve free-handedly, and it will be like this. Okay, then after plotting the equilibrium curve, a coordinate of P point was given inside the question. So this will be the P point. The x-axis and y-axis will be given in the question, so we just plot the P point here, and then we need to find the C. So the C is the y-intercept here. To find the C, we need to did the first trial. The first trial, the equation will be like this: m1 is equal to negative k prime x over, in bracket, 1 minus xa close bracket im over k prime y over, in bracket, 1 minus ya close bracket im. So because of we don't know yet for this and this one, so we just cancel it, and we will get like this: k prime x over k prime y. So this and this also given in the question, so all you need to do is just take the value given and put it here. So, and then you will get the m1 is negative 1.343. Okay, so after you get this value, you need to transfer it to the y equals to mx plus c. This x supposed to be xal, and this y supposed to be ag. So what is ag and what is al? Ag is the bulk gas, while the xal is the bulk liquid. Also, this bulk gas and bulk liquid was given in the question, so all you need to do is transfer the value inside this equation. So after transferring, you will get like this: 0.38 equal to 1.343, in bracket 0.1 plus c, and then you will get the c is equal to 0.5143. This c, which is the y-intercept, you need to plot at here. After you plot it here, then you draw a line across the graph paper to the P point, and do not stop here, but elongate the line until it reach and intercept the equilibrium curve. At the equilibrium curve intersection, you will get two more points, which is xai and yai. So after you get the first xai and yai, you need to transfer it to the second trial equation, which is, for trial 2, m2 is equal to k prime x divided by, in bracket, 1 minus xaim over k prime y, 1 minus ya over im. Now this one we can find it. So if you need to find this, you need to refer to the appendix logbook, and there will be an equation for this one and this one. Because the equation is very long, so I just summarize the equation, and for this value you will get the value is 0.8238, and this value you will get 0.7199. After you get those value, just transfer to this equation, and like the first equation, calculate it, and you will get the M2 is negative 1.173. Okay, so then supposedly for every question for gas absorption, you need to do 3 trials to get the same supposedly in every gas absorption question, all you need to do is must have 2 trials and to get the same gradient point or the same M. So after you get the second trial, if the first trial and the second trial have not too much far, the value is not too far, so by right the question is complete, because in gas absorption for equimolar case, the purpose is just to find the most similar M and then the question will be done. So I hope from this graph and this explanation is very understanding, and we'll see again. Thank you.
Hi, hello and Assalamualaikum. So my name is Ahmad Firman bin Ahmad Alif. I will talking about the conclusion for our mini project subject mass transfer 1. So as conclusion, for distillation column, the general function is to separate the distillate vapor from mixture, which is happen when the liquid mixture is heated, hence resulting the formation of vapor. So generally there are 3 types of distillation column, which are batch distillation, equilibrium distillation, and also continuous distillation. The next one is gas absorption column, which is the unit used to absorb carbon dioxide from a gas stream into a liquid. So factors that will enhance the absorption rate of the process are gas solubility, volatility, gas flow rate, viscosity, and also packings. So that's all from me. Thank you.